This is section 9.5. It's on triangles and parallel lines. This is theorem 9.6. If a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. This is basically the converse to the theorem that we learned in the last section. So you have a triangle inside of a triangle. We'll say the distance from A to B is at lowercase a. We'll say from B to D is at lowercase b. We'll say this length from A to C is lowercase c. And then from point C to point E, we'll say is lowercase d. If that length, lowercase a, to B, lowercase b, is equal to C to D, then this segment is parallel to that segment. It's the converse of what we did in the last section. So we're going to try to determine if this is parallel to this. What you're going to do is check this ratio and compare it to this ratio. So here's an example. We want to see if segment TU is parallel to segment RS. So we need to check to see if 8 to 4 is equal to this piece to 5. Now notice how this piece is not given. You know this whole length is 15. This piece is 5. So that's 10. Don't put the 15 in your proportion. We're using the two pieces of this main side that gets split by that segment. 8 to 4 equals 10 to 5. Those are both 1/2. Since they're the same, these are parallel. Yes. And the reason is theorem 9.6. Here's a couple other examples. Let's determine if segment MN is parallel to segment KL. So we need to check this ratio. 4 to 6, does that equal 6 to 9? 4/6 is 2/3, and so is 6/9. They equal the same thing. So yes, these are parallel by theorem 9.6. Notice how the ratios that I'm checking, 4 to 6, 6 to 9, look exactly the same as they did on the picture. Okay, next one over here. If it helps you, you can turn your picture, turn your diagram to make it look like this one, if you think this one's the easiest. This whole side is 11. This whole side is 7. This piece right here must then be 4. 4 and 7 make 11. And the ratios I'm going to check, I'll check 7 to 4. Is that the same thing as 5 to 3? Both of these are reduced. They're not equal to each other. So this segment and this segment are not parallel. We'll talk about this theorem in the next video.